Hopefully you've already tried all the problems, and I'm going to go through these much faster than the other video. You should have had for number 1, 9x to the 4 minus 4x cubed plus 2x. So here's the setup. We're subtracting the first group from the second group. A negative needs to be distributed. So now I have 9x to the 4 minus 7x squared plus 11x minus 4x cubed plus 7x squared minus 9x. And combining like terms, nothing combines with 9x to the 4. Negative 7x squared and positive 7x squared cancel. And then 11x and negative 9x combine. And nothing combines with the negative 4x cubed. So here's my final answer. 9x to the 4 minus 4x cubed plus 2x. On the next problem, remember it's, oops, I have no idea what just happened. It's the length times the width. And that's basically going to be a FOIL problem. So my first terms are 1/5 x to the 4 times 20x squared. 1/5 of 20 is 4. And then x to the 4 times x squared is x to the 6. The outside terms are 20x squared times 2y squared. That is 40x squared y squared. The inside terms are negative 25y squared and 2y squared. That's negative 50y to the 4th. Oh, I'm sorry, that was the last terms. That's the L and FOIL. Here's the inside terms, I'm sorry. So instead of FOIL, we're doing Foley or Folly, however you want to pronounce it. The inside terms are negative 25y squared and 1/5 x to the 4. So 1/5 of negative 25 is negative 5, and then x to the 4y squared. Nothing combined, so your final answer is this. 4x to the 6 minus 5x to the 4y squared plus 40x squared y squared minus 50y to the 4. It's ugly, but manageable. Number 3, the greatest common factor of those two terms, you want the GCF of (15 and 10). The biggest number that goes into both of those is 5. You want the GCF of the x's. The most x's they have in common, well, they actually have the exact same thing, so it's just 1x. You want the GCF of the y's. What's the most y's that they have the same? 2. And then you want the GCF of the z's. What's the most amount of z's that they both have? 2, right? Dang it. Stop it. Stop the auto, whatever you're doing. Oh, there we go. Z squared. That's quite a pretty answer. Don't you think that's a pretty answer? I think I want to circle it in black because that would be prettier. A little more decoration because nobody's watching this video anyway. There we go. All right. So number 4, factor completely, 3x squared minus 48. You start by doing a GCF, which is 3. So then that gives me 3 times x squared minus 16. Both 16 and x squared are perfect squares that are being subtracted. So that's difference of 2 squares. So you square root both of them. And then you take the square root of both of them. You make a minus version and a plus version. And you leave that 3 out front that's there. You don't get rid of it. So we have a minus version of the x in 4 and a plus version. And factor means you just leave it in factored form. Stuff that's being multiplied. Number 5, we are going to factor that area right there. First, check for GCF. Do 9, 30, and 25 have anything in common? No. So we start with our cross method. What multiplies to AC? Well, AC is 9 times 25, which is 225. What multiplies to AC and adds to B? B is negative 30. And that is negative 15 and negative 15. So we're going to take the negative 30x and just rewrite it as negative 15x and negative 15x. So here's what I have then. I've got 9x squared minus 15x minus 15x plus 25. I group my terms together. First group, second group. The first group's GCF is 3 for the 9 and 15, and x for the x's. So remember, I'm dividing that out of each term, and it leaves me 3x minus 5. The second group is leading with a negative term, so I want to divide a GCF out that's negative. And 15 and 25 have 5 in common, and there's no x's in common. So I just divide out the negative 5. And that leaves me with positive 3x minus 5. And then I rewrite this one more time. The groups have 3x minus 5 in common. And left over, they have a 3x here and a minus 5 there. So that's expressing the area in factored form. It equals the same as this. It's just a different way of writing it. If you FOILed this back out, you would get the area of 9x squared minus 30x plus 25. I really do love my beautiful illustration up here. Now I have to scroll and take it off my screen. It makes me sad. I already miss it, and I haven't even scrolled yet. Oh, there it goes. Oh, okay. Number 6, the area of the square to the right is given as a polynomial. Okay. Determine the side length of the square. So we just determined that 3x minus 5 times 3x minus 5 equals the area. And the sides of a square are the same. So really what's going on here is this is one side times the other side. So what's the answer when it asks me for just one side, the side length? Well, it's just one of those. One of the sides is 3x minus 5. And then the last one, number 7, we're foiling these two expressions. Negative 2 times negative 1 is positive 2. Negative 2 times 5i is negative 10i. Negative I times negative 1 is positive 1i. And negative I times 5i is a negative 5i squared. I can combine these two things right now to give me negative 9i. Bring that 2 down. But we have to remember that anytime we see an I squared, we replace it with -1. Okay, I squared equals -1. And so that means I have, really right there, I have -5 times -1, which is +5. Then I'm going to put it back down here. And now I can combine this and this adds to 7. All right, all done. Go do your extra practice worksheet, show your work, take a pic, upload it to Google Classroom. Bye.